Alright guys, this won't be a very long video, but it's taken me three tries, and we're going on like an hour and a half. Been some technological difficulties. So hopefully I can get this back online for you guys. So we have the tangent line and the normal line tonight. So the tangent line and the normal line. So we've been talking about this idea that f of x is our original function, and then f prime of x is our derivative. Now our derivative is the slope at any point. Now, we've kind of taken a little step further today, and we're going to say it's the slope at any point. The slope at any point is the slope of the tangent line to f of x. So we're finding the slope of the tangent line. Now, we talked about what the tangent line was. It's a line that touches right on the edge and is perpendicular to any part of the curve. And we'll deal with that later. We've already talked about it. We're going to work our way into that a little bit more. So now there's two things you need to know: that the tangent line and the normal line are perpendicular to each other. Little upside down line there. Upside down t is perpendicular, or it's the negative reciprocal. So in other words, if we have slope, then the negative reciprocal is the slope flipped over and a negative right there. So we've got these ideas here. We know that point slope is y minus y1 equals m times x minus x1. That's our point slope formula. Now, specifically for the tangent line, our slope is our value of f prime of x. So it's actually the derivative. So our slope in this equation for the tangent line is the derivative. Now, the x and y though, the x1 and the y1, those come from the original one. Make sure you designate the difference between the two. X and y come from the original problem. The slope comes from the derivative. So how do we tackle something like this? Let's slide over here. So we have the tangent line. Find the tangent line and the normal line of this specific function. F of x equals 3x squared plus 2 to the x plus 1. Now, I have a given value. At this given value, x equals 1. So technically, I already have x1. I don't have y1. I need it. So how do I need it? I need it from the original function. Well, our original function is f of x. So we just take 1 and we substitute it in. So f of 1 is equal to this algebra, and we get 6. So my y value is 6, and my x value is 1. So here's the point on the graph. This is the point on that graph that we're going to find the slope for. Now the slope is f prime. So we're going to take f prime. F prime of f of x is going to be 2 times 3, which is 6. 2 minus 1 is 1, so we get 6x here. Remember, there's an imaginary 1 here and an imaginary x to the 0. So 1 times 2 is 2. 1 minus 1 is 0, so that x is going to disappear because x to the 0 power is 1. Then when we get to a constant, we have to multiply first. 0 times 1 is 0, so it's gone. So really what happens is every time you take the derivative of a constant, it becomes 0. Now, that gives us the equation for the slope of the tangent line. So the derivative is the slope at any point. So we have an equation for the slope of the tangent line at any point. But what specific point? We wanted at x equals 1. So we take our tangent line equation, not tangent line, our slope for the tangent line, and we plug in 1. 1, we end up with 8. Once we substitute it in. Now, what we have here is this is the slope of f of x at this point. Two separate things. So what we're saying is this. The slope of f of x at point 1, 6 is 8. So quick drawing, x squared is a parabola. This is not highly accurate, but we'll just throw it in there. if I go up to 1 and 6, my slope of this tangent line, the slope is equal to 8. At that particular point, 1 and 6. So hopefully that kind of solidifies what we're finding in your head. Now, what do I do with it? Well, I need to use my point slope. Y minus y1 equals m times x minus x1. And so what do we get? We need our tangent line. This is a y, not a g. Y minus 6, coming from our original, equals the slope at 1, and then x minus x1, which is our point that we got from the original. So what's the normal line? The normal line is y minus 6 and x minus 1, because the normal line is perpendicular, or it's reciprocal, negative reciprocal of the normal line, of the tangent line. So we end up with, we flip or reciprocate or make the reciprocal of 8 and throw the negative in front, and now we've got our normal line and our tangent line. So the graph kind of looks like this. We have our tangent line, let me move this, and then our normal line is perpendicular right here. So that's 90 degrees. And again, that's still at point 1 and 6. So we found our slope here, and this slope is negative 1 over 8. Okay? So we found our normal line, we found our tangent line for the function f at point 1 and 6, and that's how you tackle it. I hope this camera actually stuck on this time, because I don't want to do this 4 times.